For decades, the world believed Albert Einstein died a lonely skeptic, left behind by the very quantum revolution he helped spark. History remembered him for his stubborn refusal to accept a universe ruled by chance, his famous spooky action at a distance, dismissed as a relic of a fading mind. But what if his greatest mistake was actually his most profound prophecy? In this exploration, we bridge the gap between two worlds, the microscopic ghost of quantum entanglement and the cosmic giants we call black holes. We reveal how two separate papers from 1935, long thought to be unrelated, have fused into a revolutionary concept: ER equals EPR. From the searing heat of Hawking radiation to the mind-bending holographic principle, we dive into the battle for the universe's information. Discover how space-time itself may be stitched together by the very quantum threads Einstein once doubted. This isn't just a history of science. It is the unveiling of the final code Einstein left for us to solve, a journey from the heart of a singularity to the edge of reality.
Part 1. Einstein's Final Code: a blunder or a vision beyond time? For decades, a shadow has hung over the legacy of Albert Einstein. In the corridors of modern physics, a narrative took hold that during his final years at Princeton, the world's greatest genius had become a relic of the past. He was seen as a man isolated by his own stubbornness, clutching to an outdated reality while the quantum revolution passed him by. His famous protest, "God does not play dice," became a punchline, a symbol of a brilliant mind unable to grasp the inherent randomness of the subatomic world. But today, the tide is turning. A profound reversal is shaking the foundations of science, revealing that Einstein wasn't failing. He was playing a much longer game than we ever imagined. In 1935, Einstein published two landmark papers that appeared to be worlds apart. Decades later, they have emerged as the final code for unifying the universe.
Chapter 1. The Spooky Ghost of EPR. In May 1935, Einstein, along with Boris Podolsky and Nathan Rosen, threw a gauntlet at the feet of quantum mechanics. The EPR paper argued that the theory was incomplete because of a phenomenon called quantum entanglement. Einstein demonstrated that if two particles are entangled, a measurement on one instantly determines the state of the other, even if they are separated by the width of the galaxy. He famously dismissed this as spooky action at a distance, believing that since no signal can travel faster than light, the particles must hold hidden information. He was fighting for locality, the idea that things can only be influenced by their immediate surroundings. Chapter 2. The Bridge Through Time. ER. Just 1 month later, Einstein and Rosen published a second paper, this time focused on the geometry of space-time. To solve the problem of singularities, points where the density of matter becomes infinite, they proposed a mathematical bridge. This is the Einstein-Rosen bridge, known to us today as a wormhole. It was a masterpiece of general relativity, describing a shortcut through the fabric of the cosmos. At the time, no one, not even Einstein, saw the connection between the spooky particles of the microworld and the massive bridges of the macroworld. Chapter 3. The Great Unification. ER equals EPR. For 80 years, these two ideas lived in different universes. EPR was quantum, ER was gravity. But in 2013, physicists Leonard Susskind and Juan Maldacena proposed a breathtaking identity:
ER equals EPR. They suggested that the spooky entanglement connecting two particles is actually a tiny microscopic wormhole. If this is true, then space-time is not a void. It is a tapestry stitched together by billions of quantum threads. In this section, we see that Einstein's failure to accept quantum mechanics led him to discover its most profound secret. He wasn't just a skeptic. He was the architect of the holographic principle, showing us that the information of our 3D world might be encoded on a 2D boundary, much like the data on the surface of a black hole. Albert Einstein didn't lose his way at Princeton. He left us a map, and only now, nearly a century later, are we finally brave enough to follow it to the edge of reality. Part 2. The EPR Paradox and Spooky Action at a Distance. In May 1935, a headline in the New York Times sent shockwaves through the scientific community. Einstein attacks quantum theory. Far from a simple disagreement, this was a sophisticated intellectual strike. Alongside his colleagues Boris Podolsky and Nathan Rosen, Einstein proposed what is now known as the EPR Paradox, a mathematical argument designed to prove that quantum mechanics was not a complete description of physical reality. Chapter 1. The Mechanics of Entanglement. Einstein's critique centered on a phenomenon that seemed to defy the very laws of logic. He pointed out that according to quantum mechanics, if two particles have once interacted, they become entangled. Even if these particles were separated by millions of light years, the theory suggested that measuring the state of one particle would instantly determine the state of the other, without any delay whatsoever. To Einstein, this was an impossibility. He famously dubbed it spooky action at a distance, spukhafte Fernwirkung. Chapter 2. The Conflict of Two Worlds. Why was Einstein so troubled? It came down to two fundamental pillars of his worldview. 1. Locality. The principle that an object is only influenced by its immediate surroundings and that no signal can travel faster than the speed of light. 2. Realism. The belief that physical properties like position or momentum exist objectively even before we measure them. Einstein argued that if the second particle knows what happened to the first one instantly, it violates the cosmic speed limit of his own theory of special relativity. He believed the universe must be local and real. It must make sense. Chapter 3. The Hidden Variable Debate. Einstein wasn't trying to say that the results of quantum mechanics were wrong. He was arguing that the theory was incomplete. He famously compared it to a pair of gloves. If you find a left-handed glove in your drawer, you know the one in the other room must be right-handed, not because of magic, but because they were created that way from the start. He believed there were hidden variables, internal mechanisms we simply hadn't discovered yet. In this section, we see that for decades, Einstein's EPR paradox was seen as a philosophical nuance. However, we now know that this spooky action is a fundamental reality of our universe. What Einstein viewed as a flaw in the system has become the cornerstone of the next technological revolution, from quantum computing to the possibility of a quantum internet. He didn't disprove quantum mechanics. He uncovered its most haunting and powerful secret. Part 3. The Einstein-Rosen Bridge, a pathway through space-time. In an extraordinary twist of scientific history, just 1 month after challenging the foundations of quantum mechanics, Einstein shifted his gaze from the spooky behavior of atoms to the very fabric of the cosmos. While the world was still reeling from his attack on quantum theory, he and Nathan Rosen published a paper that would birth one of the most enduring icons of science fiction, the wormhole. Chapter 1: Erasing the Singularity. Einstein was deeply unsettled by singularities, mathematical points where gravity becomes so intense that the density of matter becomes infinite, and the laws of physics break down. To eliminate these mathematical blemishes, he and Rosen utilized the equations of general relativity to propose a radical geometric solution. Instead of a dead-end singularity, they envisioned a throat that connects two distant flat regions of space-time. Mathematically, they had created a tunnel, the Einstein-Rosen bridge. Chapter 2: The Great Divide. ER versus EPR. For the next 80 years, the scientific community treated these two 1935 discoveries as completely unrelated pillars of physics. 1. EPR, the microscopic, dealt with the ghostly entanglement of particles in the quantum realm. 2. ER, the macroscopic, dealt with the massive geometric warping of the universe's fabric, the bridge. One was a theory of information and probability. The other was a theory of gravity and geometry. They were seen as two parallel lines destined never to meet, one governing the atom, the other governing the stars. Chapter 3: The Hidden Connection. Physicists spent decades trying to choose between them or find a way to make them coexist. They believed that the spooky action of particles had nothing to do with the bridges of space-time. But they were wrong. In his quest to disprove quantum mechanics, Einstein had accidentally provided the blueprints for its ultimate unification with gravity. The bridge and the spooky action weren't just related, they were two sides of the same cosmic coin. The macroscopic geometry of the universe, it turns out, may be built entirely out of microscopic quantum connections. Part 4: The Black Hole War and the Holographic Principle. In the 1970s, the world of physics was rocked by a revelation from a young Stephen Hawking. He proposed that black holes, the ultimate cosmic traps, were not entirely black after all. Through a process now known as Hawking radiation, he calculated that black holes emit heat and slowly evaporate over eons. This discovery ignited a crisis that threatened to tear down the laws of physics: the black hole information paradox. Chapter 1: The Information Paradox. The paradox was simple yet devastating. If a black hole eventually evaporates and disappears, what happens to the information about the matter that fell into it? According to the fundamental laws of quantum mechanics, information can never be destroyed. But according to Hawking's original math, that information simply vanished from the universe. Chapter 2: The 20-Year War. What followed was a 20-year intellectual battle. On one side stood Hawking, insisting that the information was lost. On the other were physicists like Leonard Susskind, who realized that if Hawking was right, the very foundation of science, predictability, would crumble. To save the universe from this information catastrophe, Susskind and others proposed a solution more mind-bending than science fiction: the holographic principle. Chapter 3:
the universe as a hologram. They argued that information is never truly lost inside the black hole. Instead, it is smeared out and encoded on the two-dimensional surface of the event horizon, rather than being stored in its three-dimensional interior. Think of a credit card hologram, a flat 2D surface that contains all the data required to project a 3D image. In this view, everything that falls into a black hole leaves a digital fingerprint on the surface. This principle implies a staggering possibility for our entire reality, that our 3D world might actually be a projection of information stored on a distant 2D boundary. By trying to solve the mystery of the black hole, physicists stumbled upon a new way to describe the cosmos, one where the macroscopic volume of space is just a shadow of its microscopic quantum data.
Part 5. ER equals EPR, the ultimate unification. In 1997, a young physicist named Juan Maldacena published a paper that would become one of the most cited works in the history of theoretical physics. He provided a mathematical Rosetta Stone, proving that a universe governed by 3D gravity could be perfectly described by 2D quantum interactions on its boundary. This was the birth of the ADS-CFT correspondence, the mathematical backbone of the holographic principle. But the true eureka moment arrived in 2013, when Maldacena and Leonard Susskind proposed a breathtakingly simple equation: ER equals EPR. Chapter 1. The Cosmic Thread. The hypothesis is as bold as it is beautiful. It asserts that the spooky quantum entanglement between two particles, EPR, and the physical bridge connecting two points in spacetime, ER, are actually the exact same phenomenon. According to this theory, quantum entanglement is not just a strange correlation, it is a microscopic wormhole. Spacetime is not a passive, empty stage where the drama of the universe unfolds. Instead, spacetime is an emergent property, literally stitched and woven together by billions upon billions of quantum threads. Chapter 2. Stitching the Fabric of Reality. If you were to snip these entanglement threads, space-time itself would fall apart. Gravity, the force that holds planets in orbit and galaxies together, is revealed to be the macroscopic manifestation of microscopic quantum connections. This realization bridges the 80-year-old canyon between Einstein's general relativity and quantum mechanics. The spooky action Einstein once doubted was in fact the very glue he was looking for to unify his vision of the cosmos. We have finally cracked the code. The universe is not a collection of separate objects, but a vast, interconnected web, where the smallest subatomic particles and the most massive black holes are linked by the same geometric bridges. Albert Einstein may have left the stage in 1955, but his 1935 mistakes have become the pillar of the 21st century's most profound discovery, that the heart of the atom and the heart of a black hole are one and the same. Reality is not what it seems. It is a quantum hologram, woven by the very maverick who refused to believe in a universe of chance. Part 6. The Legacy of a Genius. Bridging the cosmos. It has taken nearly a century for the rest of the world to catch up to the sheer scale of Albert Einstein's intuition. For decades, the history books painted a picture of a man who had lost his way in the clouds of Princeton. But we are now realizing that his so-called blunders were in fact the final blueprints for reality.
Chapter 1: The Architect of Reality. What Einstein dismissed as spooky and ghostly has become the bedrock of modern physics. The EPR paradox didn't prove quantum mechanics was wrong. It revealed that the universe is far more interconnected than we ever dared to imagine. By questioning the completeness of the subatomic world, Einstein forced us to discover quantum entanglement, the invisible glue of the cosmos. His Einstein-Rosen bridge, once a mere mathematical curiosity to avoid physical singularities, is now seen as the structural support of the universe. Through the lens of ER equals EPR, we now understand that geometry and information are one and the same.
Chapter 2: We are all connected. As we stand beneath the vast starlit sky, we are no longer just observers of a distant void. According to the Holographic Principle and the theories of entanglement, the separation between here and there is an illusion. Every atom in your body, every spark in your brain, could be tethered to a distant galaxy millions of light years away through the very microscopic bridges Einstein envisioned 90 years ago. We are not living on the stage of the universe. We are woven into its very fabric. Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible." Today, thanks to his refusal to accept anything less than a unified truth, we are finally beginning to comprehend the final code.
Thank you for joining me on this deep dive into the mind of a genius and the mysteries of the void. If you found this journey through space-time fascinating, please show your support by giving this video a like, sharing it with fellow explorers, and subscribing to Nok Lik Studio. Your support helps us continue to uncover the secrets of the cosmos. Thank you so much, and we'll see you in the next discovery.